How are you?
Good. So what do you got for me tonight?
So tomorrow in class we're learning how to simplify radicals. I don't really have any problems, but I just want to know it before I go in tomorrow.
Okay.
So yeah.
All right. It's a good subject. What are these numbers right here?
Yeah, I don't know.
Well, try to figure it out.
Um,
Those are perfect square numbers.
uh,
In other words, the first one is 1 squared, second one is 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared.
mhm.
When you have a radical that you're trying to simplify, the one equation that you want to apply is this one right here.
Okay.
Okay? So I could make 8 be 2 times 4, or let's make it 4 times 2. Right?
All right.
Well, what's that equal to? Based on this.
That's equal to which one's what?
Okay? Based on the fact that the square root of a times b is equal to the square root of a times the square root of b, what is the square root of 4 times 2?
8.
Square root of 4 times square root of 2.
Oh, well, 3. What?
Hold
I'm
on.
so confused.
Yeah. Where are you confused?
Like, uh, how, what is, I don't know,
Tell you what, let's do a few more examples and I think you'll be clear on it.
okay.
The square root of 4 is equal to what?
Square root of 4 is equal to 2.
So that's really what square root of 8 is it's 2 times square root of 2.
Uh-huh.
That's simplified. Now, let's do some others.
Okay.
What's square root of 12? And the name of the game is factoring 12. Find factors of 12 where one of them is a perfect square number. One of these over here. Those are your perfect square numbers. So how can you factor 12 where you can factor it 6 times 2, but neither of those is a perfect square number? What's another way to factor it?
Well, factor what, 12?
Uh-huh.
6 times 2?
That doesn't have a perfect square number in it.
Does it need to?
Yes.
Okay.
That's the requirement. That's all the requirement is. It's real simple. It's square root of 4 times square root of 3. There's your perfect square number. Again,
Okay.
square root of 4?
2.
So root 12 simplifies to that. Okay, let's keep going. Hold on. You'll get it. It's pretty straightforward once you do a few of them.
Okay.
It's all about factoring the number that's in the radical. That's what it comes down to. Factoring the number that's in the radical. And making sure that one of those factors is a perfect square number. In other words, you don't want to factor 20 as 10 times 2. Neither 10 nor 2 is a perfect square number. So how would you factor 20?
Ooh, you would do 4 and 5.
Perfect. 4 is a perfect square number.
Yeah.
Okay?
So only one of them have to be perfect square,
Exactly.
right?
Only one of them.
Okay.
In fact, almost never is it both of them. It's always one of them.
Okay.
Factor 27.
9 and 3.
And always put the perfect square number first.
Okay.
What's that become?
3, 3.
3 root 3.
3 root 3.
Okay? Now, there are some that best way to describe it is to give you one. Now, if you're not sure, just start dividing 48 by some of these perfect square numbers. It's not divisible by 9. It is divisible by 4.
Uh,
So what is it?
it would be 4 and 12.
Which is?
2 root 12.
But root 12 isn't simplified. Remember, we just did root 12. What was root 12?
4 and 3. So 2. Oh my. Okay. So yeah, 2 root 4 root 3, and
So
then
what
it
is
would
that
be.
final answer?
Would it be 2 plus 2 root 3?
Not plus. These are multiplied, all of them.
So 2 times 2 root 3.
You got it. Now,
Oh, you have to. Okay.
yeah, you just keep extracting whole numbers wherever you can. That's the secret of simplifying. However, notice this took us 3 steps, which is fine. But I can also do it in 1 step if I happen to realize that it's also 16 times root 3. 16 times 3 is 48. So there was actually a factor of 48 that was bigger than 4. That was also a perfect square number. This gets me to the answer almost instantly. Same answer, but not as long because I started with a higher perfect square factor. Now, that's not to say that you can't do it this way. You can always do it you can always do it the long way. Just keep breaking it down. Every time you find something that looks like it can be broken down, break it down. Okay? Hold on. You'll get this. This is actually pretty easy. It's not. Once you get it, you know it forever.
Okay.
Remember, you have to factor 10.
All right. Okay, so it'd be
Correct?
yeah, none of them worked though.
Exactly. This is a true statement, but it is not a simplification of root 10. Root 10 is root 10. You do not change it. Well, I shouldn't do that because it is equal, but you don't change root 10 into 2 radicals. You only change it if one of them is a perfect square number and you can pull it out. In other words, it only is simplified if you can pull out a whole number. Okay, so we don't do that. How about this one? What is that simplified?
Root 2.
Again, it's root 3 times root 2, right? These two numbers have to multiply together to that number.
Okay.
But neither of those is a perfect square number.
Right.
So we do not do that. In other words, when you run across a root 10, it simplifies to root 10. When you run across a root 6, it simplifies to root 6. When you run across a root 8, it simplifies to 2 root 2. This one simplifies. The other two do not.
Right.
Okay. In other words, the secret is not only to factor the number and find one of those factors be a perfect square, but the maximum one is helpful. Now, let me complete my list. That's 7 squared. That's 8 squared. That's 9 squared. That's 10 squared. That's usually all you have to deal with.
Mm-hmm.
So how are you going to factor 200? Where one of those factors is a perfect square number, and preferably the biggest perfect square number. In other words, 4 goes into 200, 25 goes into 200, and 100 goes into 200.
So it would be 102, right?
What's that turn into? Square root of 100.
10, root 2.
Yeah, we did that in one step. Let me tell you the slow way to do it. Let's say you don't see that 100 is a factor. Well, I can see that 50 is a factor. 50 is not a perfect square number. Let's try 25. 25 times 8 is 200. What's that turn into?
Would that be,
Go one step at a time. You don't need to jump straight to the final answer. In other words, what's the square root of 25?
Square root of 25 is 5.
Now, we know that root 8 is not simplified. What does root 8 equal to?
Root 8 is 4 root 2. Well, root 4 root 2.
What's that turn into?
That turns into 5 or 10 root 2.
Same answer we got the first time, only it took 4 steps. So I think you can start to see that the bigger you can find the factor, in other words, I got lots of choices of factoring 200. I can factor it like this. I can factor it like this. I can factor it like this. Okay, so I can do any of those, and they all have perfect square numbers in it. There's a perfect square, there's a perfect square, there's a perfect square.
Right.
You want to find the biggest one, but it is not vital that you find the biggest one. If you find the second biggest one, you'll still get the correct answer. It'll just take you a couple more steps. Okay? So that's the secret. That's all there is to it. I can give you any one now, and I would expect you to be able to get it.
Okay.
Let me give you some. And that's it. When you get to that class, you're going to know exactly how to do it. Do it step by step, just so I'll know what you're doing.
Alright, so the square root of 50, that would be 25 and 2. and then that would, square root of 25 is 5, so that'd be 5 root 5.
5 root 2.
Or 5 root 2, sorry.
Be careful about that mistake. That's a common mistake.
And then that would be the answer.
Do it however you can do it.
Okay, so...
Do it in the most efficient way. You can do it in steps if you need to.
Okay.
The one thing this does require, let me just mention this, is that you know how to factor numbers. And a calculator doesn't help you here. A calculator will not help you factor 80.
It's going to be 16.
What? What is it?
16 and 5.
Beautiful. Most people don't do it that way. They do it 4 times 20.
Yeah.
Okay, well,
then, yeah, from 16.
Let's compare it to 4 times 20. There's nothing wrong with this way. It's just a little slower. Now what? So that's 2 root 20. Now what?
Yep. Then it would be 2 times 5, which is 10. 10 root.
Put the perfect square first.
Okay, so it'd be... Well, what?
What I mean by that is you put the square root of 5 first. I'm going to put the square root of 4 first.
Okay.
The reason is that's a whole number. I want that in front. I don't want it behind the square root of 5.
Mm-hmm.
So that becomes 2 times 2, root 5. Same answer we got when you did it the more efficient way, but 2 steps longer.
Mm-hmm.
Okay? So these are a piece of cake. It's just you got a couple of ways you can do them. You can do them the slow way or the hard way.
Right.
Look at this. That's important.
Okay, yeah, I'm confused. I don't know how to do that.
Well, look at that. What I have is the square root of a ratio, a over b. Well, that's the square root of a over the square root of b. So what's the square root of 9 over 4?
Would it be 3 over 2?
Yeah. Let's do it this way, though. I prefer to do it this way. Okay? In other words, that says exactly what this does. And that becomes 3 over 2. In other words, you have a few basic rules regarding radical signs. Really, there's only 2. The 2 you have to remember. And they're the following. Square root of 2 numbers being multiplied together is the square root of the first number times the square root of the second number. The square root of 2 numbers being divided is the square root of the numerator divided by the square root of the denominator. These 2 rules will cover pretty much anything. All right. Test you a little bit more on them.
Alright, so that would be 5, 4 over 2.
It's the square root of 25 over the square root of 4. Start there. In other words, do not try to turn 2 steps into 1 step. Create some problems for everybody.
Then it would be...
Not make mistakes in math, do it 1 step at a time. What is that?
On top, it would be root 5, root 4, and then on the bottom.
No.
Or, sorry, 5, root 4.
No, just 5. Square root of 25 is 5.
Oh, yeah.
What's on the bottom?
On the bottom,
square root of 4.
That would be 2.
There's your answer. Got it?
Yep.
Okay. Let's make it a little bit harder. I think you got all the easy ones. I mean, I think you understand those for sure. Start with step 1. What is step 1?
Alright, well, square root of 1 is 1.
Hold on, don't get ahead of yourself. Just fill it in. That's the secret to math. It really is. Remember what the square root of a over b is. It's the square root of a over the square root of b. Right?
Right.
Now simplify. What's the square root of 1?
1.
Alright, what's the square root of 2? Square root of 2. What's wrong with that answer? Have they taught you that?
No.
There is a convention in math that you're not supposed to have an irrational denominator. So, square root of 2, the square root of anything that is not a perfect square number is irrational. In other words, I'm going to write irrational numbers right here. These are all irrational. Not square root of 9, that's 3. Square root of 10, square root of 11, square root of 12, square root of 13, square root of 14. In other words, anything that's not a perfect square number is going to be an irrational number. Okay, it's like pi.
Right.
Irrational. So, the secret is, how do you rationalize an irrational denominator? I can take any fraction and multiply it by the number 1. Okay? Important distinction. It's not like an algebraic equation. If I have an algebraic equation, I can do anything I want to the left side as long as I do it to the right side. Anything. But when I have a fraction, the only thing I can do is multiply it or divide it by 1. If I square the top and square the bottom, I've changed the value of that fraction.
Right.
But if I can multiply it by 1, let's multiply it by that 1 right there. That is 1. What does that give me for an answer?
1, 1.
No, multiply numerators, multiply denominators. What's 1 times square root of 2?
1 root 2.
What's square root of 2 times square root of 2?
2.
Therefore, 1 over square root of 2 is usually written like that. They are exactly the same number if you put those in your calculator. But the one on the right has a rational denominator. And that's what math insists upon. Never going to let you get away with answers like that. Rationalize that for me.
Okay. So that would be root 3 over root 3, and then...
Well, not quite. I'm going to multiply it by root 3 over root 3. There's my 1. What does that give me?
That gives you... Well,
what's the numerator?
Root 3?
What's the denominator?
Root 3?
No? Root 3
1?
times root 3 is 3.
Right, 1.
Not 1. What's root 7 times root 7?
Oh, oh my god. It would be...
7.
What's 7?
In other words,
So,
root anything times root the same thing is that number. Root
right.
5 times root 5 is what?
5.
Root 119 times root 119 is what?
119.
Okay, there you go. You got it. Notice that when you rationalize these fractions that are not rationalized, like this, that's not rationalized, you get something like that. That looks very similar. If you put that into your calculator, you get the exact same answer as you get there. The reason you have to have a rational denominator is because division is all about dividing something up into a certain number of parts, right?
Right.
Well, I can divide something up into 3 parts, but I can't divide something up into the square root of 3 parts. The square root of 3 is not a fraction. I have no idea how to split a piece of pie up into square root of 3s. Can't do it. Don't know what it means even. So that's where that convention came, is where you're not supposed to have an irrational number in the denominator. However, math has it all the time. If I have 1 over pi, pi is irrational. I can't rationalize that. There's nothing I can multiply top and bottom by to rationalize that denominator. So I got to live with that. Okay? But when you have a radical sign in the denominator, you do not have to live with it. You can always rationalize it.
Right.
All right. Blake, I'm going to let you go. Hopefully, let that sink in, because you'll be way ahead of it when your class gets to it. I will talk to you next time. Have a good night.
You too.